In this video, I'm going to look at some of the phrasing used in some of the Leaving Cert exam questions. Someone sent me a message after I went through this question here, asking me why I kind of skipped over some of the parts in the question. At first, I wasn't actually sure what they meant by skipped over, but then when I looked back through it, they said, well, you never looked at this, or this, or say this bit down here, or then in the last bit, this. Okay, so why did I skip over them, or what do they mean? So the reason I skipped over them is because I've been doing enough exam questions at this stage to know where to pick out the important parts of the exam question. Now, some people won't be that familiar with exam questions, so it might throw you. What do these things mean, or why are they even there if they don't seem that important? Well, they generally don't write them in your maths book, so a lot of the questions you're doing, you won't see this, so it might look a bit different. That's the first thing. Second thing to note is we can look at them. They're not completely useless as such, but they're probably not the most important part of the question. So let's talk through, first of all, exactly what does it mean. So a lot of it is to do with what number systems our answers are going to be part of. So this E here means is an element of, so it looks almost like a euro sign. So they're telling us that X is an element of the number system OR. Now OR stands for reals. We also have Q in that question there as well. But I'm going to go through all the different number systems that you could possibly have. So it didn't actually affect how I answered the question, but it could affect how I might display my answer, or tell me a little bit, maybe give me a little bit more guidance on whether my answer might be right or not. That's not going to tell me if I got the correct answer or not, but we can see if our answer is in the correct form. So first of all, if I look at OR, then is our set of reals. Okay, so that one's a nice easy one to remember because it begins with OR. We have OR is reals, saying that N is naturals. Now Z and Q, unfortunately, they do not actually begin with Z and Q, so they're a little bit trickier. So let's talk about our real numbers first. So real numbers are loosely defined, and this isn't really a definition at all, but it's basically every number you've ever seen is a real number until you do complex numbers. Then you start looking at some imaginary numbers which are not real numbers. So real number is any number that is not imaginary. So any number not imaginary, just write in shorthand. So that's not a strict definition, but it's good enough to explain what they are. So every other number set, bar the C down the bottom, these are all part of the real numbers. Okay, so N, Z, Q, and then the bottom, that or less Q, they are all part of the reals. So N is another one which most people will remember, which is the naturals, because nicely enough, that begins with N as well. Then we need to remember what naturals actually are. So they're all positive whole numbers. So we do not include 0. So 1 is the first natural number, and that goes up as high as you want. Once it's a whole number, then it is a natural number. Next, we have Z. Z, unfortunately, this one does not begin with Z. Z are integers. They are just all whole numbers, which could be positive, negative, or 0. They can go down as low as you want or up as high as you want. So our natural numbers are actually a subset of our integers, because every natural number is an integer as well. Okay, then Q are our rational numbers. So this is essentially any number that can be written as a fraction, more specifically a fraction of integers. So the way I write this is P over Q, so there's your fraction, where P and Q, P and Q are both elements of Z are integers. Okay, so what does that actually mean? Well, most numbers you see are rational numbers. Even our natural numbers and our integers, they're all rational numbers, because you could write any one of them as a fraction over 1. 3 can be written as 3 over 1. Minus 1 can be written as minus 1 over 1. So they can be written as rational numbers. So what numbers are not rational then? Well, that actually brings me into the next set of numbers, which they don't get their own letter for, but this is just set notation. That backslash means without. So this is OR without Q. So it's the remaining reals which are not rational. So something that's not rational we call an irrational number. Okay, so OR, real numbers without Q, without the rationals, are irrational numbers. So they are still real numbers, just they're not rational. Okay, they cannot be written as a fraction of integers. So can't be written as a fraction of integers. Now, they might be harder to come up with if you haven't seen them already before, which probably most of you have. So examples of irrational numbers, to kind of more specific, you have your square roots that don't go in evenly. So you could list a lot of them. Or else you have two other numbers you'll see quite a bit of are pi and e. Okay, so they're examples of irrational numbers. They're essentially decimals that go on forever and never have a recurrence. So they're not a recurring decimal. So therefore, they cannot be written as a fraction. Okay. Now, some of you might be thinking, well, if we can write a real or a natural number as a fraction, can we not just write an irrational as a fraction and now it's a rational number? Well, no, because in our definition of rationals, it has to be a fraction where the top and bottom of the fraction are both elements of z, so they're both integers, and in this case, root 2 there is not an integer. So they're the most common number sets we'll see. After that, we do have this C down here, which is for our complex numbers. Okay, so these are ones that can be written in the form a plus bi. Okay, and in this case, I squared is equal to -1. So I'm not going to go into too much detail on that, but that is the basis of our complex numbers and our imaginary numbers. So that I is our imaginary number, which is the square root of -1. So technically speaking though as well, all our real numbers are complex numbers. Now, that might sound a bit weird. How are real numbers complex numbers? Well, complex numbers is a bigger set of numbers and will include the reals, because a real number is just a complex number where the b part is equal to 0. Okay, so that will be a real number and it's within the complex numbers. So some complex numbers are real numbers. All real numbers are technically complex numbers, but then there will of course be a lot of complex numbers. Basically, actually the majority of complex numbers that you look at will not be real because they will contain a imaginary part. So for example, 2 plus 3i, that is not a real number. That is a complex number because it has an imaginary part. Whereas if I looked at the number 2 plus, or even just 2, which I can write as 2 plus 0i, that could be considered a real number because there's no imaginary part, or a complex number because it can be written like this. Okay, so all real numbers are complex numbers. Not all complex numbers are real. Okay, so that's our number systems part. And can you get a full question on number systems is another thing as well. Yes, you could potentially get a full short question on number systems. It's not extremely common. I might go through that in a different video actually. So if anyone wants to have a look at a question which is solely on number systems, let me see. So the 2012 paper 1 question 2, that's all the way back to 2012. Now, it has come up in a lot of mock papers and stuff since. That would be an example of a question completely on number systems. Usually it won't be a full short question. In that case it is, but a general understanding of it is needed for a lot of questions. So I might go through that question in a different video. Just sticking with the notation and moving away from number systems. If I look at the following, so solve, okay, solve isn't used in that question we have over there. Most people will know what solve means. So solve is find the value or values of the unknowns. Okay, so that's usually like find x equals or y equals. So find the value or values of the unknowns. Now, one thing to be careful of is that could also be an inequality. So it may actually be the range of values. So you mightn't get, so you could have the range of values of the unknown. So if it was an inequality, for example, so if you solved it for an equation, you might have, say, x equals 3, or for an inequality, you might have, say, x greater than 3. So they would both be solving equations. And sometimes there'll be multiple unknowns and you want to find the values of each of them. Okay. And so most people know what solve is. Hence and hence or otherwise, they can throw people off a little bit. So what do they mean? They're both obviously quite similar, but we have hence means, so use what you've previously found. So that would usually be in the latter parts of a question. So if you solve part A and then in part B, it says, hence do something. So actually, if I jump over to this question again for a second, hence in part B there, sorry, hence write the minimum point of F. That means you should use what you've found in part A. So hence is use what you've previously found. Then what's the difference between hence and hence or otherwise? So the or otherwise means you can use a different method if you want. Okay, now that's important to note because generally the hence way, so following on from the previous part, will generally be the easiest way of doing it, but not always. So if you see hence or otherwise, and in your head you're thinking, it says hence, I should use what I previously found, but you can also think of a different way of doing it. There's absolutely no problem with doing it a different way. And quite often it'll only say or otherwise if there is another potential way of doing it. So if you see hence or otherwise, don't be afraid to use a different method to solve it, but do have a look at what you've previously found, see if you can use that, because that will sometimes be quicker, but that doesn't mean that's the way you have to answer it. So I'll do an example of this question above here, which is on number systems, and I'll post a link to that video as well. Thank you.